lot of different vocabulary. Don't write this out yet. I just wanted to show you that there's going to be a lot of vocab words that we're going to come across as we go through, but as you look at it, you know most of it. Circle. What's a circle? A shape. Thanks. What defines a circle? Okay. You're getting there. All right. What makes a circle a circle? What do circles have that other shapes don't? They have a curve, but doesn't an arch have a curve? Doesn't a ellipse? You ever heard of a thing called an ellipse?
Yes.
It has a radius. And what is a radius? Everywhere in the circle is the same edge. So what is that? You about to say? So a radius, if you remember, remember, a radius is a segment that's in a circle that's equidistant all the way around. What happens is that segment is a specific distance. That distance of the radius doesn't change whether it's going from here to here to here. That radius stays constant. Those are all congruent. So a circle is then defined by a set of points, all these points going around. A circle is defined then as a set of points that are all equidistant to a center. That's what defines a circle. It's little things like that that you kind of knew-ish, but you kind of forgot-ish. All right. Diameter. Diameter is made up of what? Two radiuses. Where does the diameter? What does the diameter go through? The center. Yeah, it goes through the center. I mean, again, things that you know. You said you know pi. What's pi? And there's other things to it, but yes, we'll give it that. If you look into here, you know radius. Congruent circles, probably these few you don't know yet. Circumference. You know what circumference is. What's that? What? I know I got you mid-yawn. You're probably just waking up right about now a couple days ago. Circumference. How about the distance around a circle? Okay. Things like that. So for the most part, what's going to happen here today is we're going to talk about arcs, central angles, and what the relationships are. It's pretty simple as you get into it. We're kind of just slowly getting our brains back to mathing. We're not going to go crazy today. We'll just do a little bit of mathing to start with. Okay? For example, what I'd like you to do is draw a circle real quick. Draw a circle real fast. We're going to call this circle O. I don't know why. Let's call it Q. I don't like having O. Draw a circle. We'll call it circle Q. And we'll say that, excuse me, we'll say that AE and DC are diameters. Okay. Change this from green back to black. Okay, we'll say that these are circle Q, and we've got a couple of diameters.
Oh my God. I don't know.
Now, real quick, before we get too far out here. First thing I want to define is something called a central angle. We use these all the time. We're going to use central angles a lot over the course of the next few days, especially with 10.6 and 10.7. So understanding what it means is kind of important. Central angle is just going to be an angle. It's an angle whose vertex is at the center of a circle. Okay. down. So here, an example of that would be AQC. Q is the vertex, and it happens to be the center of the circle. Convenient because that's what we call it. Okay. The sides of a central angle are always radii. The sides of that are always radii. It's got to go from the side to the center to the side. So basically made up of radiuses, radii, excuse me. So this part here would be a central angle. Okay. Vertex at the center. Now, what I want you to notice is that the sides of that, it hits the circle. It hits the circle at point A and point C. And it creates an arc. Okay? You guys know what an arc is, right? Curve, like an archway, an archway. An arc. Whatever. They're annoying. Oh, hey, how are you? Anyway, so you get this thing called the central angle. The central angle runs into an arc. An arc is a portion. Oops, like, I haven't written in a while. It's a portion on a circle. It's part of the curve. Think of it that way. So you get this thing called an arc. A central angle has what's called an intercepted arc. The intercepted arc are just where the angle runs into. When you have a circle, once we start talking about how this all works together, it becomes super, super easy to deal with. So this is my central angle. This is what we call the intercepted arc. This case here, I would call it arc AC. But I put a curve over the top of it. Segments have little bars across, line segment across, and the arc just has a curve. And then what happens here is depending upon how large the curve is, will tell you the number of letters that it has. The lettering tells you the direction that it goes, just like segments and things like that. So this means it's arc from A to C. Okay. Guys, come on. The real easy thing to remember then is that the measure of the central angle, whatever the degree measurement is, so the measure of the central angle equals the measure of the arc that it hits. Okay. And when we measure angles, we measure them in what? Degrees, which means arcs will be measured in degrees. Okay. And this works out really, really, really quick. For example, if I say that angle, that AQC, is 110. What does the arc have to measure? 110. And since AE is a diameter, what does the other angle have to measure? If AQC is 110, CQE has to be 70. Very good. Means that this has to be 70, which means arc CE is how much? 70. Which makes this 110 because it's vertical, which means that's 110, which means this is 70, which means that's 70, and so on and so on and so on. Working with circles is pretty easy because there's only so many degrees. How many degrees are in a circle? Does that ever change? Nope. Okay. That never changes. So it works out rather nicely because there's not much mathing that you have to worry about. The measure of the angle will always equal the measure of the arc that it runs into. Okay. There's a couple other things that will happen here. We have to define what's called a minor arc, a major arc. Yeah, these are real easy. Let me grab this picture here real quick. Yeah, this was Q. This was what, 110? So, really, really easy here. A minor arc is going to arc is less than 180 degrees. Major arc, measure of the arc, is greater than 180 degrees. What do you think it's called if it equals 180 degrees? A what? If it's 180 degrees, that means it's half a circle, right? Exactly, it's called a semicircle. So if a measure of an arc, a semicircle, is an arc that equals 180. Now I'm generically using the word arc for this, but it's going to be really easy to more often than not, to tell what kind of an arc you have by the number of letters you're given. For example, minor arcs are generally written with 2 letters. So an example here, I would say that arc DE is 110. It's just telling me to go from arc from D to E. I figure out what the angle was that it created it, and I say that's its measure. Bless you. When I use a major arc, I'm going to use 3 letters, and it tells me which direction I'm going. So if I say measure of arc E, D, C. If I'm going from E, D to C, that means I'm looking at an arc from here to here. Well, there's a couple of ways you can figure that out. Do you know the 3 angles that created that? Okay. Do you know all the angles all the way around the circle? Okay. Could I add 3 things together? Could I take 360 and subtract 1 thing if I wanted to? Okay. It totally depends on how you want to set it up. It depends on what information you know. In this case here, since I know that I've got those 2 diameters, I knew what one of the angles were, just like when we had vertical angles before, the same properties hold true. I could have added 110, 70, and 110, got my answer. Or just take 360 and back out the arc that I'm not running into, the 70. I'll get the same response, same result. I knew the word was there somewhere. Okay. So what's 360 subtract 70? Okay. What's 180 plus 110? Convenient, isn't it? It's super, super easy stuff. See how it doesn't hit this arc here? So I can take 360, subtract out what it doesn't hit, or add these 3 together. It's totally up to you. Because when you're dealing with arcs, if you get into it, it winds up being the same stuff whether it was like segment addition or angle addition, because that's all this is. The only difference with your angles now, instead of just being acute and obtuse, if you really think about it, if you take the curved part out, you now have an angle that looks like this, and we're talking about that measurement. It's just a little bit different from what we've done in the past. It's nothing crazy. It's actually pretty quick. Okay. And so you don't have to draw these pictures out. I made a copy of a couple of examples I wanted to walk you through. What? I honestly didn't take a copy. I wasn't even. You know me? He's lying so bad. I have permission. I swear I didn't. And honestly, this time is smart. I swear I didn't take it. I swear I didn't. I had nothing to do with this one. I didn't even know. I don't believe her one bit. Yeah. We need one. The one time I don't count high enough, or just grab the whole stack and throw it at you. Right? I'm assuming you guys have plenty of spares. So. I didn't at first. You face gave it away though. Take a look, guys. Take a look at the section where you've got questions 9 through 18. And you've heard me say this pretty regularly. When you get big picture style questions, you'll have one diagram, and it's going to have a slew of different parts to it. These are the type of questions that you never, ever try to answer them in order. These are the types of things that you go directly to a diagram and fill in all the information that you can first. Okay? So according to our diagram, it said that we had a couple of diameters. Diameters create semicircles. Okay? They cut a circle in half. So they're 180 degrees on either side. So it said that I believe that PR was the diameter and QS were diameters, correct?
Yeah.
Okay. So if you look at it, PR, that means these three arcs have to add up to equal how much? 180. Well, I have two of the three. I have my 64-degree angle here, which means this is 64 here. I have 42 here, which means it's 42 there. How much is left for TS? What do you do to figure that out? Subtract, good. So if you take 180 and subtract out 64 and 42, which is what, 108, you get what? 72, right? Wait, no, I'm sorry, it's not 76. Yes, 108, yeah, I'm sorry. No, it's 106, so it's... Sorry, jeez.
Oh my God.
That's not right. Oh, wait. 108, yes, yeah. Yeah, 70. Why did I write this? Good morning, people. 180. I can't even do that. Hi, how are you? Good morning, everybody. I'm not doing anything. I never read questions. What? I'm sorry. So, what I'm getting at here, guys, don't read the questions. Never read the questions. So stop reading the questions. At this point, you know you have diameters. You have vertical angles. If this is 42, that means this is. Okay. Which therefore means that the other side has to be its supplement. So if I add the 64 and 74 together, I'm going to get 38. Now, that gets you all of what are called your central angles. So you've got your central angles, which means you know all of your arcs. Aside from not knowing how to subtract correctly, because I apparently don't know, now is when you go back and try to answer questions. Believe me, if you start trying to answer questions one at a time, you're going to get something screwed up. Okay? Start at one spot and with the information you're given and work your way out of it. So now I would read my questions. PQ, well, what's PQ? 42. ST, we figured it out. It's how much?
74.
Let's read the questions. TPS. Now, when it says arc TPS, remember, you're starting at T, you pass through P to get to S. 3 letters means it's telling you a direction to follow through to. A couple of different ways of doing it. You can add up all of them, or take 360 and subtract the 74. And what do you get? You guys agree? Ladies and gentlemen, enough of the bantering. I am. Okay? This isn't really difficult, but believe me, you're going to screw this up if you're not careful. Follow the letters. It tells you go from T. Okay, you can go a couple ways. RT was what? 42 and 74? Yeah. Is it 116, I believe?
Yeah.
Okay. RQS. Easiest way to do that would take the 360 and back out what you don't use. Remember, this isn't going to be really crazy. You just have to follow the directions of the letters. Okay? So, where we go? Take a minute or two, finish off the rest of those, and we'll check them here in a second. Of just those first 10. All right, don't worry about the rest of it yet. We're not there. We'll use the other parts here in a second. So let's see, where are we at? This is really quick. QR, we figured it out. That was what? 138? PQS would be 180 plus the 42, so what is that, 222?
Yeah.
And then TQR would be the 180 plus the 64, so that'd be what, 244? TQ, I just did that one. And then PS is going to be our 180 subtract 42, so that would be what, 138 again? And then PTR is how much? Huh? PTR? Did you write 72 for the TS? Because it should just, it's from here to here. It should be 180. Now, the other thing that's going to show up from time to time in things like this is that they're going to talk about things that are congruent arcs. Congruent arcs if you really think about it, have to be created by congruent central angles. Okay? Because you get into it, yes, ma'am. Well, I'm sorry, no. I'm sorry, I was thinking of the other one. When it's only 2 letters, always go the shortest distance. Okay, guys, whenever you have 2 letters, it always means go the shortest distance. You can have 3 letters that's a minor arc because it's just showing you direction, but 2 letters is always implied that it's always the shortest distance. Okay, does that make sense? So congruent arcs are going to be arcs that have congruent central angles. Pretty simple. But what gets weird here sometimes is you ever heard the word semantics? You're arguing semantics, just like little bits and pieces. Now, let me ask you this. Does the number of degrees ever change in a circle? No, it's always 360 degrees. You guys okay with that? Now, if I do this, are those 2 angles congruent? Which is it? Are you sure? What does the angle on the left say? What does the angle on the right say? Are those the same angles? So are those angles congruent? Okay. Are those circles congruent? Okay. The reason why the circles aren't congruent is because the radii aren't the same. Now, what will the measure of this arc equal? It's going to equal 110. What will the measure of this arc equal? Still going to equal 110. But the problem is that when you get into the difference between what's called measurement versus length, okay? When you're dealing with length, if you think about it on a track, when you're on a track, the inner rings are quicker because they're less distance around. The further you are out, the more distance you have to cover. Be okay with that? The reason being is that the radius is longer. The longer the radius, the larger the radius, the more you have to go around a curve. That's why you want to be on the inside line. Make sense? Okay. So there's going to be a very subtle differences as we get into this further. But for right now, we're just going to talk about arc measures. So flip over the sheet real quick and look at 36. Again, like I was saying, I just didn't want you guys to have to continually draw all these things. It says each game show wheel is divided into congruent sections. Find the measure of the arc. Well, pretty easy if you really think about it. Because if each of those pieces have the same angle, what do you have to do to figure out the measures of the arcs? Yeah, so can you count that? I don't know. It's going to be tough. Can I phone a friend? What's that? Don't hurt yourself, call my son. I'm not wearing sandals, can't count that high. There's 15, thanks. So if there's 15 of them, how many degrees are there? Well, I'm sorry, let me rephrase that. How many degrees are in the circle? 360. To figure out what each one of these are going to wind up being, what did you do? And you got, it's super easy. Okay. Now, as we get into this, yes, sir. Yeah, give you a second here. What happens with this stuff is just a matter of setting it up. It just counts more often. It's not horribly difficult. Do that for 37 real quick. How many you got in that one? How much? 15? Oh, yeah, how many? 24 of them, so that means each angle will be. Yeah, sometimes you get that. Now, go up to the very top of that page. Go to the very top of that page. It talks about a whole bunch of information. It says two diameters of circle N are JK and LM. Find the given arc measures if the measure of an arc JM is 165. What is this missing? Yeah. So what do you think you should do? Okay. This is where understanding how to draw diagrams comes into play big time in this unit. Circle. It says circle N, which means it's the center. Okay. And then it says you have two diameters. Diameters JK and LM. Does it matter where I draw my diameters? No. Just have to label it. So if I label this one, J, okay. And then L and M. Well, before I put in L and M, they gave me this other information. It said the measure of the arc, JM, has to equal 165. So that means wherever I put M, it has to be, does it have to be closer to J or closer to K? It's got to be closer to K. Does that make sense? Does it have to be above the K or below the K, or does it matter? It doesn't matter. I could put M here, or I could put the M here. It doesn't matter because, you all right? Yeah. Yeah, don't BS me. So if you put it, you can put it in either spot because what you're doing here is you're trying to visualize what does 165 look like. So if I put it there, that means then there's L. You all right? You guys are all kind of looking at me. Are you all right? You kind of looked at me crazy more. So if this is 165, how much is left for this?
Where?
For MK? 15. It's got to be 15 because that's a diameter, which means this is 165 and that's 15. It's the idea of can you place something given information just by guesstimating about what something would look like. That'd be perfect. And that's just a matter of filling in blanks. Okay. Now you guys take a second and flip over and do the problem at the bottom. Same idea. You have to draw the picture. Okay? Yes, sir. No, I haven't said to do any of that. I'm just using these as pictures or diagrams.
Use which one?
Just do that. The problem on the first page, the last one. It's the same, very similar to this one, where you have to draw a picture and label it out. No, I just said do the bottom of the bottom page. I'm sorry, the first page, the bottom question. On the first page. Yes, ma'am. Yes, ma'am. Yes. Draw the picture and fill in the blanks. All right, same idea. You've got a circle. It says it's circle T, which means T is at the center. You have a diameter, PQ and RS. Well, here's PQ. I'll draw it this way this time. And then it says RS, but PR has to be 35. So should R be closer to S?
No.
Should R be closer to Q or R be closer to P? It's going to be closer to P. Does it matter on what side of P it is?
No.
No, not at all. So if you know that's 90, this is about 45, that means this is probably 35-ish. It's kind of what you're doing here, guys. You're just kind of guesstimating about where things would be. And then if you take the 35 and subtract it out from the 180, what are you left with? Yeah, see how quick it is? It's just the idea that you just have to understand how to place value. Not terrible. The other. No, never mind. We'll do that. So what I want you to do tonight. Is not this. Now on this one here. A little bit of algebra here, but in all honesty, it's super easy because you've got three angles that create a diameter. You have three angles that create a diameter. What do they have to add to equal? So there's two pages. There's a 15 side and a 16 side. And again, try to do all the work off of the diagram before you do anything. I would suggest that you don't do the algebra stuff first. Do the other set of problems first. They're quicker. They're easier to work with. The algebra ones, you got to solve for x first before you can figure out your angles and then go on all those ways. Okay? For the algebra ones, you probably would need to, but the other ones you're just kind of filling it. You can probably fill it in off of the circle itself. There's other stuff on here that's called arc length. It's a whole different ballgame. And that will take us a good majority of the day tomorrow to get through that. It's formula work, but you kind of really, really, really have to have a calculator tomorrow that simplifies and works with fractions and things like that. Okay? Especially one that has pi in it, that works with pi in the fraction bar. It makes life easier. Okay? And we'll go from there. Did I have enough for you guys this time? Good. That was good. Didn't do much. Nice. Yours? Would have been nice if the temperatures were a little bit warmer, but whatever.